What does it mean to measure the world before the world is ready to believe you can? Imagine a hand in lamplight, steady over bronze, stone, or water. No electricity, no glass lens, no machine in the modern sense. Only patience, repetition, and the quiet conviction that the universe can be read if one learns where to look. Across deserts, river valleys, mountain ridges, and ruined cities, people once stood in silence watching shadows move, stars return, waterfall, metal point, and weight shift. They were not chasing spectacle. They were trying to make sense of time, motion, distance, and the hidden order beneath ordinary things. For generations, we have told a simpler story about the ancient world. We have imagined early civilizations as brilliant in myth and architecture, but limited in precision. Their monuments could inspire awe, we said, yet their science remained mostly symbolic, approximate, incomplete. And then from time to time, something interrupts that comfortable narrative. A disc etched too carefully, a pillar cut to follow the moon, a chamber shaped for sound with unsettling control, a rod, a basin, a ring of stone, each suggesting that long before modern laboratories, some people were measuring reality with astonishing discipline. Perhaps these objects are not proof of lost super-civilizations or hidden powers. Perhaps something more human is true, and therefore more moving, that curiosity has always run deeper than our histories allow. That our ancestors were not merely surrounded by mystery, but were actively studying it, testing it, refining it, and handing fragments of insight from one generation to the next. This is a story about those fragments, not a tale of certainty, but of traces, of instruments half remembered and knowledge partly erased, and of a question that lingers like a distant bell. How much have we underestimated the people who came before us simply because they learned to measure the invisible in ways we no longer expect? What if the oldest precision instrument was not built to conquer the sky but to listen to it? In the dry light of ancient Mesopotamia, the night began long before darkness. Priests, scribes, and watchers climbed to high places where the horizon opened wide, carrying tablets, memory, and a discipline sharpened by repetition. They watched Venus arrive like a promise, Jupiter drift with patient authority, and Saturn move so slowly it seemed to test human attention itself. For them, the heavens were not decoration. They were a clock, a calendar, and perhaps a language. Among the fragments left behind is the image of a bronze disc, circular and exacting, marked with rings and minute divisions that suggest more than ornament. It seems to belong to a world already fluent in pattern, not merely gazing upward but comparing, adjusting, predicting. One can imagine a hand turning a pointer across its face while another pair of eyes measures the height of a star just above the Earth's edge. A small motion below, a vast motion above. Between them, understanding. What makes such an object so compelling is not the temptation to exaggerate it, but the opposite. Even if we resist every grand claim, we are still left with something remarkable. Evidence that careful people, working without modern optics, may have built tools capable of tracking recurring celestial behavior with impressive consistency. That would not mean magic. It would mean patience accumulated into method, a civilization learning, night after night, that truth can emerge from observation long before theory gives it a name. And yet the deeper mystery is not only the instrument itself, it is the kind of mind that made it possible. Someone believed the sky could be divided, recorded, and revisited. Someone trusted that wandering lights were not random after all. Perhaps that is where science truly begins, not with certainty, but with the quiet refusal to look at wonder and call it chaos. Could a pillar of stone keep time not by the sun, but by the moon's quieter breath? Picture a narrow passage in ancient Egypt just after dusk. The air is cooling. The last warmth slides off black stone, and a slim band of light reaches across a small courtyard toward a solitary obelisk. It is not grand in the way we expect Egyptian monuments to be. It does not tower over temples or announce the name of a king. Instead, it stands with a kind of private purpose, dark and exact, its surface marked by shallow cuts so subtle they might be missed by anyone not trained to look. And yet those cuts appear to do something extraordinary. As light and shadow move across the stone, the marks seem to register not the march of the sun, but the slower rhythm of the lunar month. Not a rough estimate, something finer, something deliberate. The grooves narrow and widen in a way that hints at close attention to the moon's uneven pace, as if the makers understood that night itself is not perfectly regular, only pattern. What makes the object so haunting is its restraint. No triumphal inscription, no dramatic myth carved into its sides. Only a repeated phrase that feels less like ceremony than observation. An eye attending to the breathing of the night. That is a startling image. It suggests that for someone in that place, under that sky, the moon was not simply a symbol of mystery. It was a phenomenon to be tracked, compared, anticipated. If so, then the obelisk asks us to reconsider the old division between sacred time and scientific time. Ancient people may not have separated those worlds as neatly as we do. To them, precision could be reverence. To measure the heavens carefully might also have been a form of devotion. And perhaps that is why this stone still unsettles us. It implies that long before modern instruments, there were minds patient enough to notice that even the night has a pulse, and brave enough to build something that could keep listening. What if a circle of stone was less a monument than a machine for listening to the horizon? At first light, the landscape of ancient Britain can feel almost unfinished. Mist hangs low over the grass. The earth seems to hold its breath. And then the stones emerge, one by one, as though they have risen from the ground rather than been placed there. We know them as ruins now, weathered and silent. But there was a time when they stood within a living landscape of ceremony, memory, and watchfulness. Among the most enduring questions is whether certain stone circles did more than gather people. Their arrangement suggests intention beyond symbolism alone. Some openings align with the solstice sun, yes, but others appear to echo lunar standstills, those rare moments when the moon reaches its farthest northern or southern rising points. To notice such a pattern requires years of patient observation. To build for it requires a society willing to transform memory into architecture. This is where the stones begin to change in meaning. They are no longer only relics of ritual. They become repositories of accumulated attention. Each upright slab, each gap, each sightline may have functioned as a fixed reference in a world without paper charts or mechanical clocks. You return season after season. You watch where the moon appears. You compare one year to the next. Slowly, the monument becomes a kind of public instrument, turning the open sky into something readable. That does not reduce its mystery. It deepens it, because the more carefully these places seem to track the heavens, the more human they become. Not evidence of impossible knowledge, but of communities gathering across generations to refine a shared act of noticing. The sky moved, the stones remained. Between motion and stillness, understanding took shape. Perhaps that is the quiet genius of such places. They remind us that knowledge does not always begin in books or laboratories. Sometimes it begins outdoors in cold air, with a patient eye and a question repeated across centuries. Where exactly will the moon return? Can water become a clock when the human hand is willing to trust a single drop at a time? In a quiet chamber of the ancient world, far from the sweep of empires and battlefields, a vessel waits in darkness. Its walls are smooth. Its opening is precise. Somewhere near the bottom, water escapes through a tiny hole, not in a rush, but with the disciplined patience of gravity. A drop, then another, may have time made audible, time made visible. Before gears and springs, before the minute hand and the digital pulse, there was this intimate bargain between observation and flow. To us, a water clock can sound simple, almost primitive, but simplicity is often the disguise of profound intelligence. For such a device to serve any real purpose, its makers had to understand more than the fact that water moves downward. They had to shape the container so the changing pressure would not distort the reading too badly. They had to mark intervals, test conditions, compare results, and correct for the subtle way nature resists perfect regularity. In other words, they had to turn a fluid and restless element into a disciplined witness. That is what makes these early timing devices so compelling. They reveal a civilization confronting one of the hardest problems in human life: how to make the invisible measurable. A shadow can tell you something about the hour, but only under the sun. Water carries time indoors, into temples, workshops, courts, observatories. It allows people to coordinate speech, ritual, labor, and study. It transforms duration from feeling into reference. And yet even here, certainty remains out of reach. Water trembles, temperature shifts, the vessel empties. Every measurement carries a margin of doubt. But perhaps that is the deeper lesson. Precision has never meant perfection. It has meant humility before error, and the decision to keep refining anyway. A drop falls, then another. And with each one, ancient hands seem to say the same thing modern science still says. The world may not yield exactness easily, but it can be approached patiently, one careful interval at a time. What does it mean to hear a building before you understand it? Deep inside an ancient structure, sound behaves strangely. A footstep does not simply fade, it returns. A whisper lifts upward and seems to linger in the stone. A single clap breaks apart, then gathers itself again in a place where the air feels almost shaped, as though the room were not only built for shelter or ceremony, but tuned. This is the kind of mystery that does not reveal itself first to the eye. It arrives through the ear. Across the ancient world, there are chambers, corridors, and enclosed spaces whose acoustics appear too deliberate to dismiss as accident. Their curves, recesses, and proportions create effects that can amplify a voice, isolate a tone, or send a vibration farther than intuition suggests. Perhaps some of these qualities were discovered by trial and error. Perhaps others emerged from generations of builders learning which forms carried speech, song, or ritual sound most effectively. Either way, the result is striking. Architecture begins to feel like an instrument. This is where measurement becomes something larger than numbers alone. To shape sound, one must notice pattern without always possessing the language of modern physics. One must test how a chant travels, how a drumbeat fills a space, how resonance changes with volume, material, and distance. Such knowledge may not have been written as equations, yet it could still be rigorous in practice. Repetition teaches. Memory records. Craft refines. And beneath that craft lies a human truth that remains familiar. We do not live by sight alone. We orient ourselves by echoes, voices, silence, and rhythm. A culture that learned to control sound was not merely decorating sacred space. It was influencing emotion, attention, and communal experience. It was discovering that the unseen can still be shaped. That may be why these places continue to move us. They suggest that ancient intelligence was not confined to what could be carved, weighed, or aligned with the stars. It also lived in atmosphere, in vibration, in the invisible architecture of hearing. And perhaps that is one of the oldest scientific instincts of all, to recognize that what cannot be seen may still be measured by the way it touches us. What if direction was once found not by maps, but by trusting the hidden pull of the earth? Imagine a traveler standing at the edge of an unfamiliar landscape. No road signs, no compass rose printed on paper, only wind in the grass, a dim horizon, and an object small enough to fit in the hand. Perhaps it is a polished stone shaped with care, perhaps a suspended piece of metal that seems to favor one orientation over another. At first, the effect would have felt uncanny, not because it defied nature, but because it revealed nature acting in silence. Long before navigation became a science of global routes and calculated coordinates, there were hints that some ancient peoples may have noticed the strange loyalty of certain minerals to the planet's magnetic field. Lodestone in particular has always carried a quiet drama. It does not flash or roar, it simply turns. Again and again with a steadiness that invites both wonder and experiment. To observe that behavior is one thing. To build a useful instrument from it is another. That leap requires imagination disciplined by trial. If early directional devices did exist in more refined forms than we usually assume, their importance reaches far beyond travel. They suggest that ancient inquiry was not limited to what could be seen directly with the eye. Here was a force without shape, color, or scent, yet persistent enough to be trusted. That realization marks a profound shift in human thought. The world is no longer only what appears on its surface. It contains invisible structures, hidden tendencies, laws that can be sensed indirectly and used with care. Of course, such tools would have been imperfect. Magnetism varies, materials differ, interpretation can falter. But imperfection does not diminish the achievement. It reveals its difficulty. To work with a force you cannot see is to accept uncertainty while refusing to surrender to it. And maybe that is the real story behind these early instruments of direction. They are not only about finding north, they are about finding confidence in a world where the deepest truths often move beneath perception, waiting for someone patient enough to notice which way they lean. How do you measure a world that refuses to stay still beneath your feet? High in the Andes, where air thins and distance sharpens, stone does something unusual. It seems to hold both permanence and motion at once. Mountains appear ancient beyond imagination, yet the earth beneath them is restless, lifting, shifting, whispering through fault lines and pressure. In such a place, building is never only an act of construction. It is also an act of reading the land. Some ancient structures in South America suggest a startling sensitivity to terrain and alignment. Their walls fit so tightly that even now they seem less assembled than grown. Their angles respond not only to the visible slope of the ground, but perhaps to deeper practical knowledge about balance, drainage, seismic movement, and the path of celestial light. What we often call monumental may also have been experimental. Stone set against gravity, platforms placed with care. Openings arranged to catch specific moments of sunrise or seasonal return. This is where an ancient measuring device may not look like a device at all. It may be a notch carved into bedrock, a line of sight between peaks, a fitted corner that distributes force, a basin that reveals the level of water or the tilt of the land. Such forms blur our modern categories. We want instruments to be handheld, separate, recognizable. But older knowledge was often embedded directly into the environment. The landscape itself became the interface between observation and meaning. That possibility changes the emotional texture of these ruins. They are no longer only remnants of vanished power. They become records of attention. Evidence that people studied how stone cracks, how rain gathers, how light enters, how earth moves under stress. They may not have named tectonics or engineering in the terms we use now, yet they clearly understood that survival depends on respecting forces larger than any single human plan. Perhaps that is why these places still feel alive. They remind us that intelligence is not always loud or abstract. Sometimes it is patient adaptation, shaped over generations. A civilization listening carefully enough to the land that even its monuments become measurements, and even its measurements become a form of belonging. What if precision was hidden in something as ordinary and as intimate as weight in the human hand? In the marketplaces of the ancient world, knowledge did not live only in temples or observatories. It moved through ports, workshops, granaries, and crowded streets. It lived in the exchange of copper, grain, incense, oil, and stone. There, amid bargaining voices and the scrape of containers across packed earth, accuracy became more than an abstract virtue. It became trust. A measure too heavy or too light could alter a livelihood, strain a relationship, or quietly distort an entire economy. That is why ancient weighing systems deserve a kind of wonder usually reserved for stars and monuments. Small carved stones, metal balances, standardized units repeated across regions. These were not merely tools of commerce. They were instruments for creating a shared reality between strangers. Two people who did not know each other could still agree on value if they agreed on measure. In that sense, the balance scale was not just practical, it was civilizational. And yet the mystery deepens when some surviving weights and measuring objects reveal a consistency that feels unexpectedly refined. Certain sets appear calibrated with such care that they hint at systems of verification, comparison, and control broader than we once assumed. Someone was checking the standards. Someone was preserving reference units. Someone understood that precision is fragile and that once it slips, confusion spreads far beyond the market stall. There is something moving about that realization. We often imagine ancient science in distant, elevated settings, far from ordinary life. But here, measurement is woven into bread, labor, taxation, architecture, medicine. It enters the daily rhythm of survival. The quest for exactness is no longer only about the heavens above. It is about fairness below. Perhaps that is the quiet lesson of these humble instruments. They remind us that civilization depends not only on grand discoveries, but on agreed limits, repeatable standards, and invisible acts of honesty. A balanced scale is a small thing, yet in its stillness lives a profound human hope that the world, at least for a moment, can be held in equilibrium, and that truth can weigh the same for everyone. What if some of the most advanced ancient measurements were made not to display knowledge, but to hide it inside plain sight? There are objects that survive history by seeming too modest to threaten our assumptions. A carved plate, a grooved rod, a ring marked with divisions so fine they resemble decoration until someone studies them closely. They do not announce themselves as revolutionary. They sit quietly in museums, archives, or excavation reports, waiting for a different kind of attention. And when that attention comes, the question is rarely whether ancient people were intelligent. It is how often their intelligence has been mistaken for ornament, ritual, or coincidence. This is especially true of artifacts whose purpose remains uncertain because they do not fit modern categories cleanly. Some seem part calendar, part calculator. Others appear ceremonial until their markings suggest repeated numeric intervals or astronomical references. A few may have served multiple functions at once, because older cultures often did not separate science, spirituality, agriculture, and governance into isolated domains. A device used to predict seasons might also guide festivals. A measurement tool might carry symbolic imagery without losing its practical value. The modern urge to divide meaning into neat compartments can make the ancient world harder to read. That uncertainty has often invited exaggeration. When we do not understand an object, we are tempted to push it toward fantasy. But the more careful and more human response is often to stay with the ambiguity. An artifact can be extraordinary without being supernatural. It can reveal disciplined observation without requiring impossible technology. In fact, ambiguity may be part of the point. Knowledge in many early societies was protected, transmitted selectively, and embedded in forms only the initiated could fully interpret. What looks obscure to us may once have been perfectly legible within a living tradition. And so, these objects ask for patience rather than spectacle. They remind us that the past is not only broken, it is encoded. We inherit fragments without always inheriting the habits of mind that made them meaningful. Perhaps that is why certain ancient measuring devices still feel so elusive. They do not merely reflect a lost world. They expose a limit in our own imagination and ask whether we are humble enough to recognize precision even when it arrives wearing the mask of mystery. Why do some discoveries feel less like answers than mirrors held up to our own uncertainty? By the time these ancient devices reach us, they are no longer whole in the way they once were. A piece is broken, a mark is worn away, the context is missing, the language half understood, the hands that used them long gone. What remains is enough to awaken curiosity, but rarely enough to settle it. And so every instrument becomes two stories at once: the story of what it may have done and the story of how we struggle to understand it now. Archaeologists, historians, engineers, and astronomers often meet at this edge of uncertainty. One sees ritual, another sees mathematics, a third sees practical design hidden beneath symbolism. None of them are necessarily wrong. The ancient world was rarely tidy. A single object could belong to ceremony, agriculture, navigation, and philosophy all at once. To measure the moon might also be to honor it. To track water might also be to order civic life. To weigh goods fairly might also express a moral idea about balance in the universe. That is why these artifacts resist simple explanation. They come from cultures that did not divide knowledge as sharply as we do. Their makers may not have separated utility from meaning or precision from reverence. In their world, observation could be sacred and symbolism could still be exact. This does not make the objects irrational. It makes them richer and perhaps more demanding of us. They ask us to think beyond the modern habit of putting science in one room and human experience in another. There is something quietly humbling in that. We like to imagine history as a ladder, each age stepping neatly above the one before it. But these objects suggest a different image, not a ladder, but a field of scattered lights. Some were lit long ago, then dimmed, then rediscovered from another angle centuries later. Maybe that is why the past keeps surprising us. Not because it was magical, but because intelligence has always worn many forms. And perhaps the hardest thing to measure is not the sky or stone or time, but the distance between what we think our ancestors knew and what they were actually capable of seeing. What endures when the instrument is broken, the maker forgotten, and the measurement itself still shaping us? Stand in any modern city and you can feel the inheritance without seeing it directly. We live by intervals, standards, alignments, calibrated spaces, and agreed units. We trust schedules, maps, balance, orientation, and repeatable observation. Much of daily life depends on habits of precision so deeply embedded that they appear natural, almost inevitable. But nothing about them was inevitable. They were learned slowly by people who had to invent ways of making the world comparable to itself. That is why these ancient measuring devices matter beyond their individual mysteries. They are not merely curiosities from vanished cultures. They are early chapters in a longer human effort to bring order to experience without draining it of wonder. A shadow became an hour. A vessel of water became duration. A stone alignment became a calendar. A weighted balance became fairness made visible. Again and again, ordinary materials were transformed into ways of thinking. And in each case, the deeper achievement was not only technical, it was social. A measurement becomes meaningful when others trust it, repeat it, teach it, and build their lives around it. Precision is never born in isolation. It belongs to communities of memory. Someone observes, someone records, someone challenges the error, someone passes the method on. In that sense, every ancient device is also evidence of relationship, of shared attention sustained across time. Perhaps that is what gives these artifacts their emotional power. They remind us that knowledge is fragile but not easily extinguished. Even when the original explanations disappear, the impulse behind them survives. The desire to compare, to verify, to notice patterns, to live less blindly inside the unknown. That desire has crossed deserts, oceans, dynasties, and ruins to reach us. So when we look at these objects, we are not only looking backward, we are recognizing a continuity. The same human need still moves through our laboratories, our satellites, our clocks, our screens. We are still measuring the invisible. We are still trying to turn mystery into understanding without losing our sense of awe along the way. What do these forgotten instruments finally tell us? How the ancients measured the world? Or how carefully we must measure ourselves? By now, the pattern is impossible to ignore. Across continents that never shared a single empire, people carved stone to catch the sky, shaped vessels to count duration, balanced goods with disciplined consistency, and built spaces that could guide sound, light, or direction. The materials were humble: bronze, water, mineral, shadow, rock. Yet through them, human beings reached towards something immense, a stable conversation with reality. That effort deserves more than admiration. It asks for a change in perspective. Too often, we inherit a view of history that flatters the present. We imagine ourselves as the first truly precise age, the first to trust evidence over myth, the first to separate wonder from understanding. But these devices suggest a more complicated lineage. Long before modern terminology, many cultures were already testing, comparing, correcting, and preserving knowledge through repeatable means. Their language may have been symbolic. Their institutions may have been sacred as well as practical. Still, the intellectual gesture is unmistakable. Look closely. Notice what returns. Build a method. Share it. And yet there is another lesson here, quieter and perhaps more important. Every age misreads the ones before it. We see fragments and mistake them for limits. We inherit ruins and confuse survival with completeness. What lasts is rarely the whole truth. It is only what time happened to spare. A broken instrument can make an entire civilization seem vague, when in fact it may once have possessed layers of practical knowledge, now dissolved by war, whether conquest, neglect, or simple forgetting. So the final mystery is not whether ancient people were capable of sophistication. They were. The mystery is how much subtlety disappears whenever memory is reduced to rubble and story. Perhaps that is why these objects still hold us. They are not relics of a dead intelligence. They are reminders that human curiosity has always been deeper, steadier, and more disciplined than our simplified histories allow. And they leave us with one lingering question. When future generations look back at what we leave behind, will they understand our measurements any better than we have understood theirs? In the end, the story is not really about strange devices buried in sand, carved into stone, or scattered through the long debris of history. It is about a habit of mind, a way of standing in the world with enough humility to admit that reality is larger than us, and enough courage to believe it can still be studied. That is the thread connecting every shadow marker, lunar alignment, water clock, balance weight, acoustic chamber, and directional tool. Each one began with a simple but radical act. Someone paid attention, and attention, over time, becomes inheritance. The ancients did not know everything. Neither do we. Their instruments were limited by material, circumstance, and the fragility of memory, just as ours are limited by the assumptions of our own age. But limitation is not the opposite of intelligence. Often it is the condition that gives intelligence its shape. Working within constraint, our predecessors learned to see pattern in movement, order in repetition, and meaning in the small differences that others ignored. They transformed the ordinary into evidence. Water became a measure. Stone became a calendar. Weight became trust. Sound became architecture. In every case, the world revealed itself not all at once, but gradually to those willing to return and look again. That may be the most human lesson of all. Knowledge is rarely a lightning strike. More often, it is a long conversation between curiosity and patience. Civilizations rise, languages vanish, monuments crack, and still the deeper impulse survives. We continue to ask where we are, how time passes, what the sky is saying, how to make truth portable, how to leave behind something another mind can verify. So perhaps these ancient measuring devices do not challenge science so much as expand our sense of its lineage. They remind us that the search for precision did not begin in the modern world. It began wherever a human being faced mystery and refused to turn away. And maybe that is what we are really measuring across all these centuries. Not only the heavens or the earth or the passage of hours, but the enduring reach of human wonder itself.